Have you ever wondered how a streaming service just knows what show you'll want to watch next? Or how a game character can walk all the way across a screen? It's not magic. The secret is repetition. And today, we're going to pull back the curtain on the engine that makes it all possible, the programming loop. So here's the game plan. First, we're going to look at why loops even exist, the problem they're built to solve. Then we'll get into the different types of loops, kind of like a programmer's toolkit. After that, we'll talk about a couple of common traps to watch out for, and finally, we'll see how you can start mastering them yourself. All right, let's start at the very beginning. At its heart, programming is just about getting a computer to do things efficiently. And nothing, absolutely nothing, is less efficient than repeating yourself over and over. This is all about why we need a better way. So, let's just ask the big question right up front. If you need a computer to do the exact same thing, say 3 times, or maybe 1,000,000 times, how do you actually tell it to do that? I mean, you could just copy and paste the code, right? Well, yeah, you could, and it would look something like this. If you want to print knack 3 times, you just write the print command 3 times. Seems simple, but what if you needed to do it 1,000 times, 1,000,000? All of a sudden, this just becomes a clunky, inefficient nightmare. There has to be a better way. And of course there is. The official name for this is iteration. It's just a fancy word for repeating a block of code. But honestly, you'll almost always hear programmers call it a loop. This is our elegant solution. It lets us write code just once and then tell the computer to run it over and over again. Okay, so this brings us to the really fun part. If a loop is the answer, what are our options? See, it turns out there isn't just one type of loop. There are a few different tools in the toolbox, and knowing which one to grab for the right job is what it's all about. First up, we've got the while loop. This one's super common, and it works exactly like it sounds. It will repeat a chunk of code while, or as long as, some condition is true. The second that condition becomes false, bam, the loop stops cold. So when do you actually use it? The key is, you grab a while loop when you don't know the exact number of times you need to repeat. Think about it like stirring a sauce. You don't decide to stir exactly 50 times. No, you stir it until it's smooth. The loop keeps going as long as the condition, the sauce is lumpy, is true. Next, let's talk about its close cousin, the do-while loop. It's a lot like the while loop, but with one single critical difference. It will always run the code inside at least once before it even bothers to check the condition. Now, why is that useful? Well, you use a do-while loop for any situation where the action has to happen at least one time, no matter what. The perfect analogy is taste testing your food while you cook. You have to take that first taste. That's the do part. Then you check the condition. Does this need more salt? And finally, we have the for loop. This is the specialist. This is the loop you call when you know, right from the very start, exactly how many times you need to do something. It's built for counting. This makes the for loop super predictable. If a recipe says to bake exactly 12 cookies, that's a for loop. There's no guesswork. The number of repeats is locked in from the beginning. Okay, so let's just quickly put that all side by side. You use a for loop for a known number of repeats. You use a while loop when the number of repeats is unknown and it might not even run at all. And you use a do-while loop when the number is unknown, but you have to guarantee it runs at least once. We can actually categorize these with a bit of programmer lingo. While and for loops are called pretest loops. Why? Because they check the condition before they even think about running. But the do-while loop is a post-test loop. It runs the code first and then checks the condition after. It's a small difference, but it explains everything about how they behave. All right, so you know the tools. Now we got to talk about the safety rules. Loops are amazingly powerful, but that power comes with a couple of classic traps that every single programmer, from brand new to total pro, needs to know how to spot and avoid. And the most famous, or maybe infamous, trap of all is the infinite loop. This is what happens when your loop's condition is written in a way that can never, ever become false. The program just gets stuck, repeating the same lines of code forever. Which, of course, leads to that panicked question we all ask at some point. If my program gets stuck like this, how on earth do I make it stop? Luckily, there's a big red emergency stop button. Your first line of defense is usually a stop button right there in your coding software. But the classic works almost anywhere method is to hold down the control key and press C. Think of it as the emergency brake for a runaway program. The other big thing to watch out for is something called variable scope. Okay, think of it like this. A variable is just a piece of information, right? Well, scope is the room that information lives in. Some info is out in the open for everyone to see, but other info is private, living only inside one specific room. Getting that wrong can really mess things up. This is so important for loops. A local variable that you create inside a loop. It's like a note you scribble on a temporary whiteboard. It's useful while you're in there, but as soon as that loop is finished, the whiteboard gets erased. If you need your program to remember something after the loop is done, you have to create a global variable outside of it, out in the main hallway, so to speak, where everyone can see it. Forgetting this is a classic rookie mistake. All right, for our final section, let's bring this all home. We've talked about the why, the what, and the what to avoid. Now let's get practical and look at the simple steps for actually building a loop from scratch. You know, it really just boils down to 3 key steps. First, figure out the exact lines of code you need to repeat. Second, wrap that code up inside the loop's container, usually those curly braces. And third, and this is the most important part, you have to carefully build the rule that tells the loop when to keep going and, crucially, when to stop. So if you're going to take anything away from this, let it be this. Loops are all about automation. Use a for loop when you know the count. Use while or do while when you're just trying to reach a goal. And hey, a little pro tip, if you're just starting out, the while loop is a fantastic place to begin. It's super intuitive. And that's our deep dive into loops. You now get the basic logic behind everything from video game animations to your online shopping cart. So I'll leave you with a challenge. Think about some simple, repetitive task you do every day. What would it look like as a loop? What would be the condition that makes it stop? It's a fun way to start thinking like a programmer. Thanks for tuning in.